Excelente. Now, that's loaded up. Good. All right, so here we have it. We've been working on this factoring, and you should feel like you have a clue, but that you don't know it all. You should feel like sometimes I can do it, but sometimes I don't know. If you're feeling that way about the factoring, you're in the right place. Now, obviously, it would be really cool if everybody could factor everything all the time. But my experience is such that it's probably going to take you until you are in full-blown test prep mode, till you get to the point where you can factor fluently, easily. It does get easy. Okay? Now, here are some homework questions. And I believe that number 7 and number 8, if you want to get a feeling for if you're doing a good job, if you got numbers 7 and 8 right, you're doing really, really well. Okay? The rest of them are much more challenging. So, let's talk about why numbers 7 and 8 come out to be what they come out to be. And by the way, I think the next series of quizzes, we'll start putting some factoring on, and there'll be some factoring on pretty much all the quizzes that we have for the rest of the year. Not necessarily all of them, but a lot of them, that's for sure. Okay, so we're using what we call the AM method. And what that means is you have to add up to the middle term and multiply out to the last term. Now, the first thing that can be very confusing about this particular method is that because the -4 comes first, and because the A comes first before AM, there's a tendency to want to begin the problem by thinking about the -4. And if you do that, you're making a mistake. It is possible to do that, but it's going to take you a much longer time to factor. The quickest, most effective way to factor always begins by looking at the M terms. In other words, how you can multiply out to -21. Now, who would like me to tell me some ways to multiply out to -21? Phoebe?
7 and 3.
All right, well, to be
Well,
more
negative.
specific, let's go -7 and 3 and +7 and -3. And the only other combination I can think of is -21 and 1 or 21 and -1. Now, those are the 4 ways that I can multiply out to -21. And by the way, this is why it is so important to begin with the multiplication one, because it gives you a limited number of possibilities. If I said to you, how many ways can I add to -4? There's an unlimited, an infinite number of ways to do that. So by going with multiplication first, it limits my choices. Now the question becomes, which of these possible pairs adds to -4? Well, clearly it's -7 and +3. So my factors are C minus 7 and C plus 3. So that's the thought process. The thought process is to first, how can I multiply out to that last term? And then once I figure out all those possibilities, the next one is to add to the middle term, okay? So now I take a look at number 8 and I ask myself, well, how many ways can I, or what's the way to multiply out to +40? The signs here are very important. And to add to -13. Oh, well, that's -8 times -5. So the factors are -8 times -5. Okay? Any questions? How many people got both of those right? All right, that's what we're looking for. If on tonight's homework, will be similar to this. If you can nail those first 2 questions, you've got what I would call the foundation. And then we need to build off of that foundation into more difficult things. Now, speaking of more difficult, this is today's lesson. And we're obviously going to do a whole lot more of this in a couple of minutes. But the problem says to factor. And what do you do before you cross the road? Look both ways. What do you do before you start to break into double packages or a double bubble? What do we do? Look for a common factor. We always want to look for a common factor. Is there a number or a variable that divides into all 3 of those terms? Is there? Yes, absolutely. Come on, end the game. Yes, there definitely is. It's a 3. So I factor out the 3, and that leaves me with b squared minus 3b minus 28. Now, up until now, And this is the big difference with today's lesson. And if you did this on your homework, I would clear, if you stopped here on your homework, I get it. I totally understand. However, after I pull out my common factor of 3, which is right here, I then need to learn to ask myself the following question. If the trinomial is left, can I then factor the trinomial? And in this case, yes. Negative 7 times positive 4 multiplies to negative 28 and adds to negative 3. So going one step further, I keep the 3, I don't lose that. But then it's b minus 7 times b plus 4. Okay? And this is called factoring completely. And we will do a lot of work with this in a couple of minutes. So we try here. Is there a factor that's common to all 3 of these terms? Yes or no?
Yes.
Yes, what is it? 2. That's not difficult. I think everybody can get that easily. Then, once you factor it out, you're left with x squared plus 3x minus 4. And here is the part of today's lesson. You need to take your thinking one more step. You need to say to yourself, can I factor the resulting trinomial? If the answer is yes, then you do it. So, how do I factor x squared plus 3x minus 4? Well, I go back to AM. And I say to myself, what 2 numbers multiply out to negative 4 add up to positive 3? Well, to get 4, I have 2 and negative 2 to get negative 4. 2 and negative 2 again, and then I have 4 and negative 1, or I have negative 4 and 1. Which one of these combinations gets you a positive 3? Right here. So it's, don't forget the 2, x plus 4, x minus 1. Now we get to number 11. And number 11, I look at it, is there a common factor? No. So I immediately turn to plan B. And what plan B says is, when there's no common factor, I'm going to cross out the first term, multiply here by it. And that's going to create x squared, that stays there, minus 11x, that stays there. God bless, 5 times 2 is 10. Then I'm going to factor that. It's x minus 10, x minus 1. But if I just multiply by 2 here, I've changed the question. So I then need to balance that out by dividing by 2 back here. And then negative 10 over 2 reduces to negative 5. And then this is the elementary school trick. 2 times x minus 1. So to me, these guys here are fundamental. You should be good at those by the end of today. These guys and these guys, numbers 9 and 11, are challenging. And you have to know 2 things. First, if there's a greatest common factor, you pull out the greatest common factor. Second, if there is no common factor, we go to plan B. And that's when we multiply and then divide back in. Yes?
Does plan B work even if there is a common factor?
Yes and no. Yes, but when you get to this step here, there can be issues unless you know how to handle it. So you're just better off doing the common factor step when it's there first. Okay? All right. Now, this guy, there is a common factor. The common factor would be 5, so I'm left with 5 times a squared minus 2a minus 3. So it's a matter of adding up to negative 2, multiplying out to negative 3. There's only 2 ways to make 3 negative. There's negative 3 times 1 and positive 3 times negative 1. In this case, I have to add up to a negative 2, so it's 5, a minus 3, a plus 1. Okay? All right, so those are, or that is, all of the factoring of trinomials and what we need to know about factoring trinomials. Okay, so the next thing that we're going to do is the quiz. Oh, I didn't give the quizzes back yet? I'll give them back in a moment. All right. All right. What was today's quiz number? It was 8AA. There we go. All right. Actually, I'm better off doing this. Where?
this it? No, this is not it.
That's not it.
So where did this go then? Okay. All right.
So, sorry for not giving you quizzes back. Let me do that right now. It's my excitement to get that back to you now. All right, Francine. Sam. Abubu. Yasmin.
You go, yeah.
White Sox.
Go.
Oh.
Emma. Isabella. Jaden. Christina. Phoebe. This is like the quiz of 80. Ivy.
Everybody forgot to shade.
Lots of people forgot to shade. Mary. Maggie. Sammy. Alex Mahabo. Kristen, or Kirsten, I should say. I misread that. Alexandra. Francesca. Alexandra, can you bring that over to Francesca? Hunter.
Oh, okay. I see now.
And Allie. Okay.
We are right there. Okay. So, now,
We all right? All right. If I were a kid sitting in class, I would look at the first question on the quiz, and I would have said, "What the heck is he doing?" I really haven't done much with 2 to the x and 5 to the x, and those are, hey, come on, hit me again. Those are exponential functions, and we've done a little bit with them. It's not like we haven't done anything with them, but we haven't really focused on them. We've kind of introduced them and pulled back. So why do I put on the test the first question about comparing these two graphs? And what I'm trying to build into you, I did it with one question on the last quiz, and I'm now doing it with a question on this quiz. I'm trying to develop in you an appreciation for all that the calculator can do for you. So if you look at these choices on the quiz, it says something about what their y-intercepts are. It says something about steepness, which one is steeper than another, and so on and so forth. And I don't think it's really possible to answer that question, these questions, unless you turn around and, I won't click. Unless you turn around and actually graph the functions. So I'm wondering how many of you actually graph them so that you could look at them and know. All right, so the first one is y equals 2 to the x. 2, here's my exponent or up arrow, it's called a caret symbol, x. And then the next one will be 5, caret, x. And then I'm going to hit graph, and I want you to pay particular attention to the graph and which one goes first. So this guy out here is the 2 to the x, and this one in here is the 5 to the x, okay? That matches the order in which I put them in the calculator. So now I want to take a look at these choices, and I want to see which of these choices makes sense. It says the y-intercept of 2 to the x is 0, 2, and the y-intercept of 5 to the x is 0, 5. I don't think so. Now, another way to interpret y-intercept is this. The y-intercept is whenever x is equal to 0. Agree? Okay. What's 2 to the 0? No. 1. Anything to the 0 is 1. What's 5 to the 0? So that means they both have a y-intercept of 1. And if you look at the graphs, it sure looks to me like they're going through the same point, and that would be 1. If you wanted to, you could look at the table, and if you want to find the y-intercept, you look where x is 0. So as I look across, I see in both cases the y-intercepts are 1. So that tells me it's either 2 or 3, because it has a y-intercept. Y-intercept just means touches the y-axis, and those are wrong. So it's either 2 or 3. Now, which one is steeper? Steeper means gets bigger faster, has more straight up and down. Is 5 to the x steeper, or is 2 to the x steeper? 5 to the x. So therefore, my correct answer is choice B. Okay? And my whole driving point behind this is you are going to take what I consider to be a challenging Regents. And if you are just an expert on your calculator, you're going to pass. That's not an issue. But I want to get lots of 85s. I want to get 80, 85, 90 for lots and lots and lots of kids. And the calculator will answer so many questions for you, but you have to learn the power of the calculator and how you can apply it to unfamiliar situations. So I would describe this particular question as unfamiliar before today. And now that we've gone over it, I think it should be obviously more familiar for the next 2 quizzes. But also, more importantly than that, girls, more importantly than that, I want you to develop a habit of, if you encounter a question and you say to yourself, well, I really don't know how to do that question, then you say to yourself, okay, maybe I don't know how to do it, but if I use my calculator, it might really help me answer something. Okay, so next up, on the set of axes below, graph 2x plus y is greater than 1. And as soon as I start thinking about graphing a line, I start thinking in terms of y equals mx plus b. And that means that I have to get y all by itself. So my first step is to subtract 2x. Y is greater than negative 2x plus 1. Now, as an aside, I did see some kids write this. And that's fine as long as you remember that this is the slope and this is the y-intercept. The slope is always the number that's in front of the x. Generally speaking, I would prefer that you write it in y equals mx plus b form. It's not a big deal. You don't have to. You could definitely do it like this. But this is more the way you're likely to see things, so I think you're less likely to make a sloppy mistake. What's the slope here? Negative 2 over 1. Now, there were a number of people who did a positive slope. And the question is, why? Did you remember one way of perceiving this? Positive slopes go up, negative slopes go down, 0 slope in the middle, and this guy is no slope. If you remembered that way, then you would have to go down because it's a negative 2 slope. But sometimes kids do this. Well, let's go to the y-intercept, which is 1. I begin at 1. Sometimes kids go, they see the negative 2, and they go kind of to the left, thinking that negative means go left. And the problem with that is, if you do it that way, it means the following. There's a couple of different ways to interpret it, and then I'm going to tell you the way I think it's best to be known. One way is to say, since the top is negative, I'm going to go down 2. And since the bottom's positive, I'm going to go over 1. And this is a correct way to interpret it. All right, so that's a good way. Now, another way to interpret it is this. Some people will say, okay, well, I'm going to do it as a positive 2 over a negative 1. So they'll say I should go up 2 and then 1 to the left. Up 2, 1 to the left. I'm getting the same line, so that's fine. But then some people will do what I think is the best way, which is just to realize that it's a negative slope. Since it's a negative slope, you have to go down. So I'm just going to go down 2 over 1, down 2 over 1, down 2 over 1. Again, I get the same exact line. But then there are some people who say this. They say, okay, it's negative, so I have to go 2 down and I have to go left 1. In other words, what they do mistakenly is they kind of do both of them negative. And they'll go, okay, I have to go down the 2, but then I have to go 1 to the left. Down the 2 and 1 to the left, and now they end up getting the wrong line. And the reason for that is really simple. What's a negative divided by a negative? Positive. So now I'm not getting a value of negative 2, I'm getting a value of positive 2. So never, ever, ever do it that way. I think the best way to graph is to just say that you know better, that you know a negative slope goes down, and all slopes go left to right. So it's down 2 over 1, down 2 over 1. Now I'm going to plot these particular points. So here I go. I plotted the points, and now I'm going to, don't forget the arrows on the ends, and last but not least, so, oh, by the way, when I graded this, it was 20 points for the first question, and then I did 20 points if you got the y-intercept right. I did 20 points if you got the slope right. I did 20 points if you got broken or solid right, and I did 20 points if you shaded correctly, okay? Now, when it's greater than, do you shade above or below? Above. If it's less than, you shade. What symbol is that? Greater than. Well, actually, I should even look at the symbol over here, because it can change, depending if we multiply divide by a negative, and there's my graph. So I saw a lot of people forget to shade. A lot of people forgot. Some people messed up on the slope. Some people did a solid line. Again, we did this work probably right before the vacation, so let's make sure that we don't repeat those mistakes tomorrow. All right. Next up, last but not least, is today's question, or today's lesson, I should say. Algebra reconciled. What's today's lesson? Number 25, right? 26.
Trinomials 5.
All right, so a couple of very, I don't know if I'm going to get to every do-it question, but I'll go through some of them. These guys share a 5 and an A in common. Girls, you got to get, Sam, you got to be a lot more focused. This is some very challenging stuff. 5A times 2B minus 1. The biggest thing about factoring is this. Factoring is anti-distributive. So you always want to just check yourself by multiplying back. 5A times 2B is 10AB. 5A times 1 is 5A. In here, they share a 3 and they share an H. And that leaves me with G to the third minus 3G squared plus 4. I cannot factor that, it's cubed. Okay? Now, I'm going to go forward to these factors. AM. How can I multiply out to negative 24 and add up to positive 10? What's that? Positive 12 and negative 2. So that gives me x plus 12 times x minus 2. Okay? Questions? Again, such a critical skill if you can get that right. And now, a new one. Very difficult. Actually, let me take that back. Not difficult. Really weird the first time you see it. There's no x term in the middle here. You're probably thinking, how the heck do I factor it? But there is an x term. We don't bother writing it. It's 0x. So what two numbers multiply out to negative 9 and add up to 0? 3 and negative 3. So it's x plus 3, x minus 3. And this is a very special case that we call the difference of two perfect squares. And there's a pattern to it. Do you see how the x square root it and you get x and x? And then you square root the 9, you get 3 and 3?
Yeah.
What do you think x squared minus 16 would be?
4 and 4.
Positive 4, negative 4. X plus 4, x minus 4. What do you think x squared minus 100 would be? What do you think? X plus 10, x minus 10. Good. What do you think x squared minus 144 would be? X plus 12 and x minus 12. Okay. And last but not least, take a look at letter C. Is there a common factor?
There is no.
Not. So what do I do if there's no common factor?
A and B.
Plan B. Good. Multiply by 2 here, that gives me x squared plus 7x plus 6. I need to know, how do I multiply out to 6 and add up to 7? 1 and 6, good. So I'm going to go x plus 1, x plus 6. But now wait a minute. I multiplied by 2 there, so what do I have to do now? Divide by 2. And this gives me 2x plus 1, doing the elementary school trick. And this gives me x plus 3. Okay? One left, yes.
Is it okay if we kept the 2x plus 1
You can't put a half, it has to be the whole number. Okay, last but not least. By the way, what would t squared minus 25 be? T plus 5, t minus 5. What about 4x squared minus 9? A little tricky here. Not 4.
Got 2x plus 3. And
That's right.
Minus 3.
2x plus 3, 2x minus 3. Because the square root of 4 is 2. Now, I just want to code you in on one little itty bitty phrase right here. Factor completely. If you see those words, now when I was growing up in my house, if I heard the phrase Robert Carl Lindquist Jr., that meant the crap was going to hit the fan. It was time to stop and pay attention because Dad was going to start swinging. Okay? Therefore, if you read factoring completely in your mind, I always want you to say, oh, it must be 2 steps. Remember those ones we did from the homework last night? Look here. Do they share a 3 in common? Yes, they do. 3n squared minus 2n minus 3. Now, can I factor n squared minus 2n minus 3? What am I going to get there? I'm going to multiply out to negative 3, add to negative 2. What do I do that? Negative 3, positive 1. Good. Here, is there a common factor?
Yes.
Yes, what is it? 4. And that leaves me with x squared minus 9. Can I factor x squared minus 9? Yes, what do I get? X plus 3, x minus 3. What about here? Do they have a common factor here? 7x squared minus 7. What do they share in common? 7. I'm left with x squared minus 1. Can I factor x squared minus 1? Yes. What do I get? 1 and negative 1. Good. Let's go very quickly to number 5. Do they share something in common? 2. That leaves me with n squared minus 3n minus 4. Can I factor n squared minus 3n minus 4? What do I get? N minus 4, n plus 1. All right, folks, keep working. In about a week, you should be really, really good at factoring, but it does take some time. Hasta la vista, vaya con Dios.
Toodaloo, ta-ta, arrivederci, smile a lot. Ciao.